I'm going to be talking a little bit about global climate change and individual behavior, in specific people's perceptions, preferences, motivations, and risk. I'm just going to move this a little bit this way. All right. So a lot of you know already about human behavior and climate change. This is sort of a carbon cycle shown by Vaclav's mill. All of these black arrows are natural forcings. These two red arrows right here, where we use organic sediments from the land, so this is a combustion of fossil fuels, as well as deforestation, land use changes sort of increase carbon dioxide in the atmosphere, and that leads to climate change. And there are a variety of impacts of climate change. So we have increasing drought, flooding of low-lying lands, ecosystem changes, food shortenings will worsen, and this is sort of a photograph from last year's wildfires in California. So stuff's going to get pretty bad, but there's a lot of uncertainty that's related to this. So in terms of who are the major players in this phenomenon, the United States emits 22% of the world's CO2 emissions, but only accounts for 5% of the world's population. So the onus is on us right here in the United States to try to address this problem. Now, there are many ways that we can possibly try to address this problem. As John was saying, I sort of come from an engineering background, so a lot of engineers think about supply-side solutions. So let's think about how we can use carbon capture and sequestration. What that is basically capturing the carbon dioxide from power plants and putting it into underground aquifers. How do we increase renewable electricity generation? How do you incorporate efficient electricity generation? Most power plants run at around 30% efficiency. So basically leaving humans out of this equation. How psychologists try to address the problem is by looking at demand side. So how do you get individuals to change their behaviors? How do you get people to change their preferences for the amount of energy that we use on a day-to-day basis? So in order to sort of holistically address this problem, we need to combine these two as demand and supply side solutions. Yesterday, we heard a little bit about the behavioral wedges. So I just wanted to walk you through a little bit about what these stabilization wedges are. So Pakala and Sokolow in 2004 sort of thought of how can we reduce our gigatons of carbon per year from 14 gigatons of carbon per year down to 7 gigatons of carbon per year by 2050. And what they said was that let's look at a whole variety of different ways that we can do this. One example is carbon capture and storage. We can start reforestation or afforestation. We can think of different technologies like nuclear fission. We can switch over to more efficient fuels. We can start looking at renewable electricity generation. And then we have efficiency and conservation. So all of these things combined together would actually help us decrease the amount of CO2 we emit. But what they also said in their landmark paper is that improvements in efficiency and conservation offer the greatest potential to provide a wedge. So what this means is that if we have a limited bucket of effort or money, we really should be focusing on energy efficiency and conservation. And that's why all of you guys are here. So how do we look at this problem? So in terms of an overview of my presentation today, I'd first like to start off with what are people's perceptions of energy consumption and savings? So this is more of a recent research study of mine. Then how do people prefer to change their behavior? Do they prefer voluntary actions, soft regulations, or hard regulations to change their behavior? And finally, I wanted to sort of give you a few tastes of some of my current work. So let's start off with people's perceptions of energy consumption and savings. Now, if I were to ask you as an individual, what is the most effective thing that you could do to conserve energy in your life, what would you tell me? Let's say you do not know much about energy efficiency or conservation. What would you say? So that was the first thing that I wanted to look at, is that in the public, what would people say about that? Then I wanted to figure out is how accurate are people's perceptions of energy consumption. So for example, if you were to take this room, how much energy goes into cooling this room, into lighting this room, into sort of making one of these bottles for me to drink my water out of? Do people have a good idea about this? Because energy is invisible. We don't really see it. So how do people understand, or what types of heuristics do people use to sort of make sense of this world or this landscape? And then finally, what are people's accuracies related to? If I'm a woman, am I more accurate than a man in terms of my perceptions of energy consumption? If I'm pro-environmental, am I more accurate? So what are these accuracies related to? So these are the sort of 3 questions I wanted to answer with this particular project. So first, let me take you sort of through back to time. Sarah Lichtenstein et al. In 1978 thought of, all right, what do people think about risks? So there are a whole variety of risks of dying, everything from botulism, which is caused by botulism, which is caused by a bacteria that paralyzes you, to homicides, pregnancy, smallpox vaccinations, heart diseases, etc. So the whole variety of ways of dying. So what she did was she had the actual numbers of death per year on the x-axis, and she asked individuals to estimate how many people die per year from these different 30 causes of death. Now, data that lies along this dashed line, I don't think you can see my, I'm going to try using this one. Oh, that's better. So data that lies along this diagonal line means that people's perceptions are accurate. That means what you think about what you think about the number of deaths per year actually corresponds to the actual number of deaths per year. But what she showed is that for these small causes of death, people overestimate the number of people that die per year. And for these large causes of death, people really underestimate them. So do you guys have any idea why people do that? What do you say?
We're going to have fun. So some of them are under their own control, and they don't believe that their own influences cause part of it. Mm-hmm. So all this stuff where they underestimate or overestimate that is because that's the fear they can't control. That's acts of God. And then the other stuff is within their control, within their lifestyle, and they choose not to confront it.
All right, that's one possible cause. Any others? Yeah?
Denial. A lot of, when all of those points that are underestimated are within control, in my opinion. So it seems to me that the underestimation of that has to do with our not inability to accept or to fear those things that we can actually control, don't want to face.
Hey, John?
Well, habituation, I think everybody knows somebody that's died of cancer, heart disease, whatever. And when you see something about botulism or smallpox vaccination, that makes the media a act of terrorism, whatever. That's spectacular. That sticks in your mind.
That's exactly what they found. So what they term as an availability heuristic. So basically, in the media doesn't report when people die of a heart attack. But if there's a case of E. coli poisoning, if there's a case of botulism, it's in the newspaper, people read it, it's really available to them, it's available to their mental psyche. They sort of think, oh my God, a lot of people are dying from this particular cause. So they really overestimate these particular causes of death, and they really underestimate these causes. So what I wanted to do with my work is, what does this look like for energy consumption? Do people overestimate and underestimate particular behaviors? Or are their accuracies much better than what we find in terms of causes of death? So what I did was I designed an online study, which was across the United States. These are where the participants came from. All of these dots represent people that took the study. So it was 505 people. It was a national sample. The median income and other demographics were pretty, provided large enough heterogeneity for us to be able to say some interesting things.